Hey guys, it's Mr. Robeson here. We are looking at the second section, which I'm calling 4.2 of Unit 4, which is looking at how to find the mean or the expected value of a discrete probability distribution. They are the same thing, mean and expected value, just different names for the same thing. We're going to look at a couple applications, and one particular application is for lottery or raffle problems. All right, so mean expected value of a discrete probability distribution. So we've been making probability distributions. We've been taking discrete variables, like the number of wins it takes to win the NBA Final Series, since the first one in 1947, all the way up to 2020, the last series, which I believe the Lakers won. All right, and the number of times each one of those occurred. And we've been practicing going from this value, which is our x, to our p of x here. All right, so the way we did that was we added up all these numbers here. So let's see, 7 is 14, plus 9 is 23, carry the 2, 2, 3, 4, 5, 6, 7, 73 series finals. And then we take each one of these, like 10 over 73, 17 over 73, 27 over 73, and 19 over 73 is the probability of each of those. All right, we can change the decimals if we want or leave them as fraction, doesn't matter. All right, now the next thing we're going to try and do, now that we have this probability distribution, is we're going to try and find the expected value. All right, which is, if we were to do this over and over again, like many times, then on average, this is what we would expect to happen. All right, the mean, which we usually use the symbol mu for, remember, mu, looks kind of like the cursive U or an M, is the same thing as expected value, and the notation for expected value is E, what we would expect for our variable x. All right, so the way we find this expected value, or the mean, is we make our probability distribution. We make sure it's completely filled in with both the x values and the p of x values. So we've got our x values here, the number of games it takes to win the series. We've got our p of x values here, our probabilities. Then we multiply each x by its p of x. So I'm going to add in another term here, or another column here, and just say x times p of x. So I'm going to do 4 times 10 73rds, so that's going to be 40 73rds. We're going to do 5 times 17 73rds, so 5 times 7 is 35. So that's going to be 85 73rds. You can do these as decimals. We'll do the next one as decimals, I think. 6 times 27 73rds. Oh gosh, 6 times 7 is 42. Carry the 4. 6 times 2 is 12, plus the 4 would be 16, 162 73rds. And then 7 times 19, 7 times 9 is 63. Carry the 6. 6 plus 7 is 13, 113 out of 73. All right, so that's dissed up. So then we add them all up. So we just add these guys up. And the sum that we get is our expected value. So when we add these all up, that will be our expected value, which is the same as our mean. And I'm going to grab my calculator for that one. I'm not going to try and do that one by hand. So let's see, we've got 40 of them, plus 85 of them, plus 162 of them, plus 133 of them. And then each of those is divided by 73. And we get 5.75. Always ask yourself, does your answer make sense, and what are the units of your answer? All right, so somewhere between 5 and 6 games is what we're getting. That makes sense. That's a possibility because it's between 4 games and 7 games, and it looks like a lot of the data here is centered around 6 here, so it should be close to 6 because there's 27 data values there. That's the most. And this is the number of games, so we would say that this is 5.75 games. So if we had a random series and we were saying, how many wins do you think it's going to take, or how many games do we think it's going to take to win the best of 7 series? The answer for the NBA Finals is 5.75 games. Now that might seem strange because you get a decimal answer here, but this is just on average what's going to happen. Like if we did this many times, that's what would happen on average. All right, let's take a look at another example. I'll try a different color here. Orange, how about blue? Researcher wants to know the average number of children per house in a particular neighborhood, so she looks at the census data to compile the table below. Help her find the expected number of children per house in the neighborhood. So number of children is our variable. That's our x. This is just our data that we use to get our probabilities. So the first thing we need to do is we need to figure out, well, how many total houses do we have here? So if we add these up, that's 40, 55, 65, 70, 75, I think. And then we're dividing each of these by 75. So let's see, this would be 10 out of 75. This would be 30 out of 75, 15 out of 75, another 10 out of 75, 5 out of 75, and finally another 5 out of 75. All right, notice we're dividing these numbers here by the total, not the x values. Not the x values. That's the mistake that most people make when we do this. All right, now if we get them as decimals, because I said I would do this one as decimals, 10 over 75 is 0.133. 2 decimal places is usually plenty. 30 out of 75, 30 out of 75, 0.4. 15 out of 75, I think it's going to give us 0.2. Yep, 0.2. Another 10, well, we already did that. That's 0.13. And then both of these are 5. So 5 out of 75, which should be half of 0.13, 0.0666. All right, and this should probably round up, so I'm just going to put another decimal place after it, just for kicks there. All right, so now to find the expected value, we do x times p of x. We add in this other column, and now we're multiplying these guys here by these guys, and that's given us this. So 0 times 0.13 is 0. 1 times 0.4 is 0.4. 2 times 0.2 is another 0.4. 3 times 0.13 is 0.39. If you need to use the calculator, that's fine. 4 times 0.67, I'm going to use the calculator. 6 times 0.067, that 0 is important. 0.268. And then we've got 5 times 0.6067. So 5 times 0.067. 0.335. All right, and then our next step was we added these guys up. So we've got 0 plus 0.4 plus 0.4. So 0 plus 0.4 plus 0.4 plus 0.39 plus 0.268 plus 0.335. And we get 1.793. And that is our expected value. The expected, what we would get for the number of children here. It's also the mean number of children. And our units here help her find the expected number of children. So this would be this many children per house. All right, number of children per house is what we're looking at here. All right, so there we go. So that means, it doesn't mean we'd have exactly 1.793 children in any house, but that would be on average. There are 1.793 children per house. All right, that's what that means. There's our sentence. You may be asked to write some sentences. That's all you got to do. All right, piñatas. Everybody's broken a piñata before, knows what a piñata is, or maybe you have in Spanish class, like students in their Spanish class are interested in finding how many hits it takes to break a piñata. I guess there should be a tilde over there. There we go. They find the probability of breaking in a certain number of hits collected below. Find the expected number of hits it takes to break the piñata. All right, so the number of hits, 1 hit, 2 hit, 3 hit, 4 hits. That's all it took, was 4 hits at most. Probability it breaks. So these are our x's, and they're already giving us our p of x's. All right, so we need to make an extra column, or an extra row in this case. Sure, we'll go down below, since there's no room to the side. And now we just multiply down here. So 1 times 0.50 is 0.50. 2 times 0.25 is another 0.50. 3 times 0.15 is 0.45. 4 times 0.10 is 0.4, or 0.40. And now we just want to add all these guys up. So this is 1, this is 0.85, so this will be 1.85. So our expected value is 1.85, which is also our mean. And our units here is find the expected number of hits to break the piñata. So this would be hits. So our sentence would be, on average, it takes 1.85 hits to break a piñata. There we go. All right, one more example here, and then I'm done. I know I'm going long. We're at 10 minutes, but just one more here. The raffle or lottery example. So a school uses a raffle as a fundraiser. They sell 1,000 tickets for $3 each. Prizes for the raffle are one grand prize of $200. So there's one of those for $200, and then 3 other prizes for $100. What is the expected value for someone playing the raffle? All right, so we need to set this up. We need to find x's and p of x's. So x would be what could happen for one individual person. How much money could they win? So we'll call this winnings. And this would be money. So like we've got one person who's going to win $200. But they've actually paid $3 to play. So it's 200 minus the $3 they paid to play. And they actually end up plus 197. So I'm going to put the plus sign there just so I remember he's winning. Then we've got 3 people that are going to win $100, but they also paid $3 still to play. So they lost $3, but then they won $100, so they end up plus 97. And then everybody else who buys a raffle ticket just loses their $3. So they end up -3. So we do have negative options available here, especially when we're doing the raffles or lotteries. All right, now the probability. So there are 1,000 tickets. So everything that happens is out of 1,000. So one person wins this 197. So that means we have 1 out of 1,000 getting 197. 3 people win $100. So 3 people end up $97. So 3 out of 1,000. Everybody else loses $3. So we've got one person there, 3 people, so that's 4. So that means 1,000 minus 4 is 996 other people out of 1,000 end up losing $3. All right, now we're going to do our expected value. So now we've got our probability distribution, and we just need x times p of x. All right, so we're just going to multiply 197 times 1 over 1,000. I'll move it over here so we can see. So 197 times 1 divided by 1,000, it's going to be 0.197. So there's a contribution of, plus 19, 20 cents, something like that. Then next we've got 97 times 3 divided by 1,000. There we go. 0.291. 0.291. And then finally, we do have negative here. The way we do negative on our calculator is down here at the bottom. -3 times 996 divided by 1,000. And that gives us -2.988. So this guy right here is our biggest contribution because there's just such a probability of that happening. And then to get our expected value, we have to add these guys up. And yeah, this last one is negative. So it stays negative. So we've got this last one here, plus 0.291, plus 0.197, -2.5. All right, so -2.5. That means people are losing money. That's how raffles work. That's how lotteries work. They on average, people lose money. That's how they work as fundraisers. Otherwise, they wouldn't be raising funds. So we'd say, on average, a person who buys a raffle ticket can expect to lose $2.50. All right, so that's on average. Again, a couple people are going to win. 4 people are going to end up winning money, but 996 people are going to end up losing money. And on average, even with these people that win money, on average, people end up losing $2.50. So that means the raffle is going to make $250 per person times 1,000 people. So the raffle is going to make $2,500 as a fundraiser. All right? That's how these fundraisers work. That's how your lottery works. All right? Otherwise, if they weren't making money, they wouldn't do it. All right, so that's it. Check out the homework. You got this, guys.